Yo, what's going on? Link here, and today we're gonna go for another daily LeetCode question. To be completely honest, I already have done this one before, and I did this one today already because I had an interview today, and I just wanted to have this one as kind of like a warm up for the interview. But I'll just go through my thought process. It wasn't that hard, so I'll probably be able to do this real quick right now. Also, I just wanted to do it before because just to have make sure I had the streak here. I'm trying to do those over here are problems that either I wouldn't be able to I wasn't able to solve or I just forgot. But okay, well, let's see. Let me restart this thing. Boo. Okay, so question 2294, partition array such that maximum difference is k. So you're given an integer array nums and an integer k. You may partition them into one or more subsequences, such that each element nums appear in exactly one of the subsequences. Return the minimal number of subsequences needed, such that the difference between the maximum and minimum values in each subsequence is at most k. A subsequence is a sequence that can be derived from another sequence by deleting some or no element without changing the order of the remaining elements. Okay. Uh. Okay. So now that I'm thinking, so the approach that I took was like, okay, so let's say we have, I'll whiteboard this real quick. Okay, so let's say we have this example right here. So what we're going to happen is we're going to say, okay, so 3, 6, oh, this difference is already bigger than 2, right? So we're going to do 3, 1, which is okay, and then we'll do 2, okay, this is still okay because the difference is still okay, and then 5, 5 is not okay anymore, so 3, 2, 5. Wait, sorry, 3, 2, 3, 1, 2, and then 6, 5 is the other one. So we don't want to change the relative order of the arrays. Like this statement kind of doesn't matter for this question because we don't have to return those elements, right? So what I thought in the first place was, okay, so let's, if we need, whenever we have this question of like, oh, the difference must be k, and we have to get the minimum of something, kind of this, it's kind of like greedy algorithm stuff. I always think, okay, so if we want to like a specific difference and the minimum ways we can divide the entire array into subarrays, we might just sort the whole thing because sorting, we're gonna get all the elements as close as possible from each other, right? And then let's say we have k is equal to 2. If so in this case, for this subarray, the difference is 1 minus 3, right? 3 minus 1, which is equal to 2. So if we try to expand this into 5, 5 minus 1 is equal to 4. So this go already over the limits that we have k, which is equal to 2. And then at this part, we can't be greedy and say, okay, so if the array is sorted and we already know that this difference right here is bigger than k, we don't have to even look at this one, right? So my approach was like, okay, so we're gonna go, let's see, let me grab this whole thing. Okay, so let's go, we sort the array in order, and then we go, okay, so 1, 2, this is okay. 1, 3, this is still okay, right? Because we always compare with the minimal element. At any point, if the difference go over k, we can be greedy. We can be greedy and say, okay, that's one subarray. We can move to the next one. So this case we have 1, 2. This is okay. 1, 3. This is also okay. 1, 5. This is not okay anymore. So we must start a new subarray from here, right? And we will have to go five. Oops. We have to go 5, 6, all the way to the end, and that will be the second subarray. And again, because we don't have to return those subarrays, just the number of subarrays that we created, we don't have to worry about the order, so we can just sort and then return the values as we walk through them. Let's see if anything else. Yeah, I think that's it. So basically just iterating through the array, tracking the minimum value, and then make sure we always have the difference less than or equal to k. And once we get over that k, we update our new starting of the array, which is the minimal sub value that we found so far, and then we keep going. So yeah, let's put this into code. Okay, so first we're gonna sort the array, so nums sort, and then we need the current minimum that we found so far, and let's just say that that's the nums and x0. Uh, let's see, and then we need oh, rest. This we're gonna count the number of subarray that we created. Let's start with 0, and then let's iterate through the array. So for I in range, we don't want the first element because we already added as a current minimum. Oh, this is what, okay, I'll go back to that later. So 1 all the way to length nums, and then if nums index I minus current minimum that's greater than k, that means that we can't form a subarray, a valid subarray with that one, right? Because the difference will be already greater than k. So we can just update, we can actually do rest plus 1. That means that we already built a subarray, and then we can update our current min. The current min is basically the minimum value that we found so far that is part of this subarray, and the minimum value is also the starting element of the new subarray that we are currently building. So res plus equals 1, we all can also update the current minimum. The current minimum is equal to nums I index I, and at the end we can just return res. But the problem here is that once we start iterate through the array, we have this one as the current minimum. So this is part of the first subarray, right? So once we're done with this, we build this subarray already. So we don't start with 0, actually, we start with 1. And only after we found an invalid element, then we're gonna build the previous array and then start a new one. So yeah, I think that's all I did. Let's see. Okay, let's give a submit. Okay, cool. All right, performance. So yeah, I think that's all I have for this one. So yeah, thank y'all for watching and see y'all next time.